This is Unit 1, the Screencast 2. I'm going to be going over a few example problems of dimensional analysis of metric units. So, dimensional analysis is, like I have stated here, the most useful skill of chemistry. It's going to allow you to switch between units of the metric system. It's going to allow you to solve problems with chemical reactions. In general, it's going to help you figure out what an equation is if you don't know it just based on the units. It's an incredibly useful skill, especially in college after you leave here. So, what we're going to use it for today is converting between units of the metric system. So before we get started with examples, some tips. You always want to include units throughout the problem. So every single step along the way, you're going to want to write out your units as you go. I'm going to show you that in just a second. It's always set up the units so that the unwanted one cancels. And what that means is the unwanted one is going to go on the bottom of the fractions we're going to be writing out. So it says working straight across, values on the top are multiplied and values on the bottom are divided. Okay, so I'll show you what that looks like. So here's the first example we have. I have 24 grams. I want to know how many kilograms that would be. For all these problems, you always start with what you're given, 24 grams. So to do the factor label method, how I like to do it is to draw a little t-graph like this, and what I want to get rid of goes on the bottom. That's grams. What I want to get, kilograms, goes on top. From here, you have to look up or potentially have memorized the conversion factor. So we know that kilograms are huge. We know that for every 1 kilogram, we have 1,000 grams. Now, the way I have this set up, grams are going to cancel with each other, and kilograms are going to be what's left over, and that's what we want. That's what we want as our answer in our units. So, I said working straight across, values on the top get multiplied, so that's a 1, it's not going to do anything, and values on the bottom get divided. So what you do is just 24 divided by 1,000. Right, so not too surprisingly, that comes out to be 0.024. 0.024. Now, most of you will say, I could have done that without setting this up. I could have done that most likely in my head. But the truth is, these problems are going to get a lot harder. They're not going to be changing by factors of 10 all the time, so you want to get good at this method before things get difficult. You want to be using it now. Let's look at another example. 500 milliliters is how many liters? Again, start with what you're given. 500 milliliters. Set up your T-chart here. Milliliters is going to go on the bottom, so it'll cancel, and liters goes on top. We know that milliliters are really, really tiny. Milli means thousand. So there are 1,000 milliliters in 1 liter. Again, I made sure to set up my units so that the ones I don't want cancel and the one I want ends up on top. So this is just like before. It's going to be 500, and because it's on the bottom, it's going to be divided by 1,000. That comes out to 0.5. 0.5. Again, make sure you put a unit on your answer, so that's 0.5 liters. Right? Pretty easy. Now, when these problems get to be two-step, if you're going from very small units, such as milli, centi, deci, to very large ones, such as deca, hecto, kilo, you always have to convert to the base unit first. Now, what the base unit is are the ones that you wrote down in the table. Meters, grams, Celsius. All of those base units are the ones that you wrote down in the table. So we're going to look at an example using those two steps. We're going from 18.64 milligrams to decagrams. So start with what you know. 18.64 milligrams. Set up my chart here. I want to get rid of milligrams, so it goes on the bottom. Because it's two-step, I want to go to grams first. That is my base unit for this case. You're going to extend your t-chart here, get rid of grams, and get what we want here, decagrams. Decagrams. Okay, so we need our conversion factors. Milligrams are really small, so there's going to be 1,000 milligrams in 1 gram. Decagrams, on the other hand, are huge, so there's going to be 10 grams for every 1 decagram. You might have to look up that conversion if you don't remember it, but deca in general means 10. So I'm going to make sure I set this up so that these guys are canceled. Milligrams cancels with milligrams. Grams cancels with grams, and we're going to end up with decagrams, which is what we want our answer to be in. So 18.64. Because it's on the bottom, we're going to divide by 1,000. Because 10 is on the bottom, we're going to divide again by 10. Comes out to 0.001864. So 0.001864. Get your units on your answer, decagram, and that's it. Again, it still looks like you could have just moved the decimal and had it solved easy, but I'm telling you, you're going to be so good in chemistry if you learn this method. Just for good measure, I'm going to do one more for you. 0.836 kilograms. Whoops. Let's get rid of kilograms. Get grams. Let's get rid of grams. Get centigrams. So for every 1 kilogram, I have 1,000 grams, right? Kilograms are huge. And then for every 1 gram, I have 100 centimeters. Took me a second to remember that, or centigrams, I'm sorry. Centi means 100. Okay, so pull out the calculator. Because these are all on top, 836, they're all going to be multiplied. Okay, so that comes out to 83,600, yeah. And the unit is centigrams. Okay, so that should be enough examples to get you started. It's useful to at least save or even print out a copy of the conversion factors if you don't have them all memorized. But as you keep using them, I think it'll get easier and you will memorize them. Okay? See you next time.